Problem 31. In the given figure, three particles are fixed in a place and have charges Q1 equal to Q2, which is equal to plus 5e, and Q3 equal to plus 2e. The distance A equal to 3 micrometer. What are the magnitude and the direction of the net electric field at a point due to these three particles? How many particles you have? We have three particles. So we are going to find at a point P, we have to find what is the electric field. So we have to use the formula E equal to K Q over R square. So first of all, let's write the given first. So here Q1 and Q2 takes the same value, which is plus 5e, and Q3, which is equal to plus 2e, and A value is 3 micrometer. So micro stands for 3 multiplied 10 power minus 6 meter. Now we have to find the answer for two questions. First one, we have to find the magnitude. So for finding the magnitude, so I can just use the same diagram here. So we have two diagrams. One is for finding the value of R, one is for finding the electric field direction. So let's take this diagram. So here we have to first of all, let's see the diagram. What is given here? You have three particles, Q1, Q2, Q3, and Q1 and Q2 takes the same value of plus 5e, and Q3 here is plus 2e. But what is the distance from first charge to point P? This is the distance. Am I right? R. Likewise, for the second charge, this is the distance R. And likewise, the third charge, the distance from the third charge to the point P is R. That means we have to find the value of R. Because why? We know the formula E equal to K magnitude of the charge divided by R square. So we have to use this formula for each and every charge. So that means K Q1 over R square plus K Q2 over R square plus K Q3 over R square. Clear? And also Q1 and Q2 takes the same value. And also we have to find what's the direction of the electric field. So all these things you have to do. But now what I'm going to do, let's find the R value first. So let's take this triangle A, B and C. So I'm going to give the name for this triangle. This is not the name for the charge. Actually, I mentioned ABC for the triangle. So in triangle ABC, we know we have to apply the Pythagoras theorem. So AC square, which is equal to AB square plus BC square. And here the distance between A and B is A. So I can write A square here. And likewise, the distance between B and C is A. So therefore, BC square is again A square. So what's the value of AC square here? The value of AC square is 2A square. Now we have to take the square root on both sides. Therefore, AC equal to A root 2. That means the distance from this point to this point. That means the distance between A and C, we got the answer as A root 2. So the half of this A and C gives the value of R for three charges. So I'm going to find the value of R. So what I have to do, I have to divide AC by 2. So when you divide A root 2 over 2, what you will get? You will get A root 2. I can write these two as square root 2 root 2. Am I right? So root 2 multiplied by root 2, you will get 2. So I just split these two like this. You can cancel this. So what's the value of R here? The value of R here is A over root 2. So we have to use this R value for three charges. And also we have to find the electric field direction. So what's the electric field direction? So when you bring the test charge from point P towards first charge, what's the value of the first charge? Because the first charge and the second charge takes the same value, plus 5e, and this is also plus 5e, and this one is plus 2e. So when you bring the test charge towards this first charge, what will happen? Because the test charge is positive, your first charge is also positive. What will happen? It will repel. So that means your E1 direction will be in this direction. Am I right? Likewise, when you bring the test charge from point P towards second charge, both are positive charge, and then it will be repel each other. Am I right? So now you can see your E1 and E2 takes the same charge value, but you can see the electric field direction, both are opposed to each other. So what will happen? Your E1 get cancelled with this E2. So that means no electric field for charge Q1 and Q2. That means the charge 1 and 2 does not have electric field. Why? Because E1 and E2 get cancelled each other. So that means the value for E1, which is equal to 0, and the value for E2, which is equal to 0. Why? Because you can see E1 this direction, E2 this direction. So both will get cancel each other. Clear? So only one charge is left. So we have to consider only third charge for this case. So what you have to do, we have to write the formula. As we know, the electric field, the net electric field formula is E1 plus E2 plus E3. As we already know, E1 and E2 are 0. So that means 0 plus 0 plus K. That means we have to consider only the third charge. So I have to write the formula K magnitude of the third charge divided by R square, right? So now I have to substitute the value. The value of K is 8.99 multiply 10 to the power of plus 9, and the magnitude of the third charge, because this is third charge 2e, so 2 multiplied by, we have to substitute the charge value, which is 1.6 multiply 10 power minus 19 divided by R value. What we have to do, we have to take this value. What's the value of R? A over root 2. So I have to write A over root 2. That means A over root 2. So what will happen? This root 2 will go to the top. Am I right? And also this is square. So we have to square this value. So what will happen? You will get A square over 2. Am I right? So this 2 will go to the top. So I have to write this number again. So 8.99 multiplied 10 power 9 multiplied by 2, right? Multiplied by 1.6 multiply 10 to the power of minus 19. And when you separate this, A square over 2, so the 2 will come to the top. So I can just write these two here, divided by A square, and A value is already given in the question, which is 3 micrometer, right? So 3 micro means 3 multiply 10 power minus 6 meter. So I have to write, so 3 multiply 10 to the power of minus 6 the whole square. Clear? Now I have to find the answer. Just wait. I will calculate. And here I got the answer, because 8.99 multiply 10 power 9 multiply by 2 multiply by 1.6 multiply 10 to the power of minus 19 multiply by 2 divided by 3 multiply 10 power minus 6 over the square. So here I got the answer 639.28 Newton per Coulomb, not nano, Newton per Coulomb. So we can round it this number, or you can leave as it is. So if you round it, what you will get, the net electric field is 639.1 Newton per Coulomb. So this is the answer for this question. Clear? That's it. Thank you.